Good morning, students. Let us look into encoders now. We know what is an encoder. Encoder is a device which is used to convert input data to code. As the name indicates, encoder converts input information or input data into a code. So this encoder plays a very crucial role in converting data into a coded form. There are different types of encoder. 4 by 2 encoder, octal to binary, decimal to BCD, priority encoder. We have already completed 4 by 2 encoder in the last video. Now we will see octal to binary encoder, or we can call it as 8 to 3 encoder. We know encoder has 2 to the power of n inputs and n outputs. If there are 4 inputs, 2 to the power of 2, I will get 2 as my output. Now we will see octal to binary encoder, 8 to 3 encoder. So as we are getting into octal to binary encoder, you know, when I say 8 by 3 encoder, there will be 8 inputs. Can you see the 8 inputs represented by Y0, Y1, Y2, Y3 till Y7. So I have 8 inputs. 2 to the power of 3 is 8. So 3 is your outputs. A0, A1 and A2. That is why we call it as 8 by 3 encoder. Or you can call it as binary, octal to binary. What is the base of octal? Octal base is 8. So you have 8 inputs here. So Y0 to Y7 is your octal inputs. 3 is the code which is obtained as the output. Each input line corresponds to each octal digit. Okay, so every single input line is an octal digit, and you know in encoder, at any point of time, only one input line will be active or high. Rest is all will be zero. So you should remember that at any point of time, listen, at any point of time, only one input will be high, rest is zeros. So let us start now with the truth table. Truth table is drawn between inputs and outputs. I have Y0 to Y7 inputs. So Y0, Y1, Y2, Y3, Y4, 5, 6 and 7. These are my inputs. I have 3 outputs, A0, A1 and A2. So A0, A1 and A2. And I said at any point of time only one input will be high. If Y0 is high, rest will all be zeros. So for the first case, Y0 is high, rest is all zeros. In the second case, Y1 will be high, rest is all. Y0 is 0, Y2 to Y7 is 0. In the third case, Y2 is high, rest is all zeros. In the fourth case, Y3 is high. So similarly, every point of time, only one input will be high, rest is all will be zeros. If I fill this truth table, I will get a inverse diagonal ones for an encoder. Now what is the output I need to write in the place of A0, A1 and A2. Now see, in the first instant Y0 is 1. So 0, Y0, 0 is 1. So it is 0, 0, 0. In the second case Y1 is 1. 1 in binary is 0, 0, 1. 2 in binary is 0, 1, 0. 3 in binary is 0, 1, 1. So fill it with binary numbers 000 to 111. This is how the circuit is. If I give input information 000010, it gives my code as what? 001. Okay. Now I've got my truth table. Now you understand how to fill the truth table. Now let us see how to write the logical expression for the truth table. This is my truth table which I have filled with Y0 to Y7 will get a diagonal ones, and A0, A1, A2 fill it with 000 to 111 pattern 000, 001, 010, 011, 100, 101, 1110 and 111. Now what is that I need to do? I need to write expression for A2, A1 and A0. Now let us start with A2. In A2 column, check the places where you have ones. So I have 1 here, 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 here. So I have 4 positions with 1. So for this 4 positions, which of the input is high? For first position, Y4 is high. For the second position, Y5 is high. For the third position, Y6 is high. For the fourth position, Y7 is high. So my output, my A2 expression is Y7, Y4, Y5, Y6, Y7, Y4, Y5, Y6, Y7. A2 is Addition of y4, y5, y6, y7. Okay, now let us write for A1. Now check A1. What are the positions which is high? Which is high in 1, 2, 3, 4 positions. So the first position is high in y2. So write y2 plus. Second position is high in y3. So y2 plus y3. The third position where it is high in this place. So go and see its respective input is high, y6. So y2 plus y3 plus y6. And the fourth one is in this position. Go and check which of the input is high, y7. So I have written y2 plus y3 plus y6 plus y7. Similarly, do it for A0. A0 has ones in 1, 2, 3, 4 positions. First position is y1, second position is y3, third position is y5, and last position is y7. So 1, 3, 5 and 7. So fill this. Once you are done with logic expressions A0, A1 and A2, you need to draw the logic diagram. How many inputs? Y0 till Y7. So I have written all the inputs. Now what is my A2? A2 is 7 plus 6 plus 5 plus 4. Go to 7, take a wire. Go to 6, take a wire. Go to 5, take a wire. And go to 4, take a wire. Connect those 4 inputs to what gate? OR gate. Plus means OR gate. Connected to OR gate. This is my output A2. Do similarly for A1. A1 is 7, 6, 3, 2. So 7, 6, 3, 2 connected to a OR gate. A0 is 7, 5, 3, 1. So it is 7, 5, 3 and 1 connected to OR gate. So you can implement a circuit 8 by 3 or octal to binary. 8 is the base of octal. You can call it as octal to binary encoder or 8 to 3 encoder. This is the circuit which we have designed. This is the block and this is the circuit. So this circuit has 8 inputs and 3 outputs. Thank you.